Is the audio video is clear to everybody? Tell me first of all. Do comment करके बोलिए now here. Am I audible to all of you? Tell me. Right. Yeah, actually, so the most accurate, so give rank predictor which is live, you can utilize this rank predictor. You can use this gate rank predictor prepared by this academy, the most accurate gate rank you can get. Right. So you can see now here. So this we started the from 24th onwards we have started new batch. We have started the networks and digital हमने शुरू किया. You do follow this batches for 2028 के लिए भी नया batch and ESC 2025 का rankers you can have a look at. And these are the ESC 25 rankers. And we have the Unacademy UNA, the great AI platform of Unacademy. So there are the three modes are there. Here you can see now voice mode, quiz mode, smart summaries. So with this mode you can utilize according to your convenience. You can directly speak with UNA if you ask, prepare a quiz and so topic and so question, it will create the quiz according to a requirement level. Also you can able to decide. And these are the test series which is live, you can have a look at. And we do offer the two subscription. One is a plus wala, the other one is a iconic wala. And plus में आपको क्या क्या चीज मिलेगा, you can see the top educators classes मिलेगा, live doubt solving होगा, evaluated mains test series and structured courses, PDF, live test, unlimited access. And iconic में additionally what we will get now here, physical notes and personal coach भी available होगा. And the mentorship program you can have a look at. So these are the GATE 2025 rankers from Unacademy. Right. Chalo, let's start our discussions. Last we have completed some problems. Now we'll continue the remaining problems. Right. Yeah. Chalo, next problem. Take the next problem. Consider this SR flip-flop having input and the clock signal as shown in figure. Now they are asking to find the characteristic equation. Yeah, you tell me the characteristic equation. Here, which we have, what tell me now? Q. So what will get to tell me now here, this output of XOR gate is X XOR with Q. Now if you see this thing here, the S is directly going to here now. What about this R you tell me now here? X XOR Q whole bar. And this is which flip-flop now? SR flip-flop. SR flip-flop, the working we know the characteristic equation. And what is the characteristic equation of a SR flip-flop? You tell me now here. Q plus, which is equal to what? Tell me now. S plus R bar into Q. Right. So now we can place now S and R values. So that is characteristic equation which could be given as S is equal to X XOR Q plus R bar will come it as what? Tell me now. So this is R. So what about this R bar is a 2 times complement ले लिया तो ये वापस X XOR Q बनेगा. X XOR Q into q. Then you can tell me now what will come. This q plus is a x XOR q. I have taken common. Then it is 1 plus q. So 1 plus q is what? Tell me now. 1 only. So finally what I'll get this q plus now? That is x XOR q. Okay. Next, assume that the initial value of q is 0. After applying a clock signal to the given circuit, the subsequent states of q is. After that, what will be the next state they ask you to find? Here you see this thing here. What they given now? J value is given as 1 and k value given as what? Tell me now. Q se diya. This q se diya na. So this type of connection, which is called as a toggle mode, you tell me now. This type of connection, which we can call it as what? Tell me now. Toggle mode. Yeah, toggle mode we can say. In toggle mode, yeah, tell me now. So output continuously will changes. So initial state is given as what? Tell me now. 0 diya. So 0. Then what will be the next state will come? You tell me now here. 1, next 0, next 1, next 0. Like this. Aisa chalta hoga na, you tell me. So that is 1, 0, 1. Like this will continue. So what will be the option? You tell me now here. So here initial state they are asking subsequent. Iske baad they are asking to find. Or the next state will come it as 1. Next 0. Next 0. 1. Like this will continue. Why? Because this is the toggle mode of operation. Next. A modulo 16 ripple counter uses JK flip-flops. If the propagation delay of each flip-flop is p nanoseconds, the maximum clock frequency that can be used by 5 megahertz, then the value of p is. So first of all, they given this as a modulo 16 ripple counter. So that means how many flip-flops are there? You tell me now. The number of flip-flops are 4. Yeah, JK flip-flop. Ripple counter means what counter? This is the asynchronous counter. They given a maximum clock frequency. So the time period, which is equal to what? Tell me now. That must be greater than n into TPD na. TPD is a propagation delay. Now this is, we can say, time period equal to 1 by frequency. So that should be greater than n value 4 and propagation delay, which is given as a p nanoseconds. Nanoseconds means 10 power minus 9. So f value given as 5 mega, that is 5 into 10 power 6, greater than or equal to what I can say? Tell me now. 4p into 10 power minus 9. Yeah, simplify करके बोलिए. What will come here? P value we need to get now here. So this is P value must be less than or equal to 1 by 20 into 10 power 6 into 10 power minus 9. So that is P is less than or equal to, you tell me now here, 1 by 20 into 10 power minus 3. So P value will come to be how much now? So this value will go to, it is 1000 by 20. So this value So that is P is less than or equal to how much you can say now? 50. The value of P is how much you tell me now? 50. Isn't it? Tell me. So finally the P value, how much here? That is a 50. 50 nanosecond, already given nanoseconds now. We should no need to put the nano again. Right. A ripple counter is made with 3 positive edge triggered flip-flops. In the output of the previous lower significant bit flip-flop is used as a triggering clock pulse of the next higher significant bit flip-flop. Then the resultant counter is what they given. You tell me now. They given a ripple counter is made of what? Tell me now here. 3 positive edge triggered flip-flops. We have a 3 positive edge triggered flip-flops like this. Okay. Edge triggered flip-flops. So here, if the output of the previous one, so this output of the previous lower significant. So if I call this is my Q0 and this is my Q1 and this is a Q2 and this is behaving like a, what? Tell me now here, clock for the next flip-flop. So like this they given. You tell me now. It behaving like a clock for the next flip-flop. So here then the resultant counter is what the positive edge triggered only. For this one we have given external clock is given. Ripple counter, if we have taken this as a asynchronous counter now, and this is T2. So this value 1 and this value 1 and this value is 1. Yeah, you can tell me now here. So this is LSB and this is MSB. So how it will behave? So tell me now. It's a ripple counter. And what is mod number? Mod 6 counter. It is up here down counter. Clock we have taken from where? You tell me now. 𝐂𝐤𝐴. And what type of trigger here? Positive trigger now. So this is. From this we can call this as what? You tell me now, plus Q. Plus Q, that means abhi this fellow which is state mein hai, sukh mein aina. That means sukh ke baad kya aega? You tell me now, dukha aega. Sukh ke baad dukha aega. That's why this is what I can say now. This is a mod 8 down counter. So this is mod 8 down counter, right? Tell me this thing. A 4-bit serial in parallel out shift register is constructed as shown in figure. The register is a right shift register. Okay. And they asking initial state of the register given as 1 0 0. Then the minimum number of clocks required to get back to the state again, same state again. How many clocks required so that we'll get back to the same state? Tell me now how many clocks required. So now here first we have, this is OR gate A plus B. Here we have what? Tell me now, A plus B, and this is C. So this will go to input now. From this, what I can say now, input now, tell me now. So this is A plus B This is 𝐿 with C. 𝐿 gate na A plus B 𝐿 with C. Okay. Now let's form a tabular form here. How many clocks required? You can see. Right, sorry. So some urgent call came. Right. You see the clock? Right. So here is a clock. Next we have A, B, C, and D. Okay. Now look at now here one by one. Yeah, tell me now. First clock, initially 0th clock. So what is the state you tell me now? So they given us 1, 0, 0, 0. We need to get back to this thing after how many clocks we'll get back the same thing. First clock when you apply, so first we need to see A and B, we should OR gate will come 1 and we should compare with the C, so that is 1 and 0, so will come 0, 0, 1, 0, 0. Next second clock A and B 1, 0, 0, 0, 1, 0. Next third clock, so 0, 𝐿 get equality detected. Both inputs are same, then only will get output is 1. 0 and will come it as 1. So that is 0 only. 0, 0, 0, 1. And fourth clock 0, 0, 0. Same 1, 0, 0, 0. Isn't it? So from this, what I can say, tell me now here. How many clocks you tell me now? That is 4 clocks. So number of clocks are how many? 4 clocks. Next, JK flip-flop shown in figure below. Yes, now you tell me now what will be this output now here. Here J value given us what, tell me now? Q bar. K value given us what, you tell me now? 1. So what I can call this is now toggle mode now. This is a toggle mode, right? in toggle mode. So that means what the sequence now here continuously changes now. Initially they given it as what will be now 0. Initially will come 0, thereafter 1, thereafter 0, thereafter 1 0 1 0, like this will continue karega. Right. Next, a 4-bit shift register has initialized the value given. The D input is derived from Q3, Q2, Q0 through two XOR gates as shown in figure. The number of clock pulses required to get the pattern 100. Tell me now, how many clocks required to get this pattern? So same pattern we need to get. So if we see here we have what tell me now, this is Q1 XOR with Q2. Oh no, this is Q2 now. This Q2. Yeah, so this is Q2 XOR with Q3. And here this is Q0 XOR with Q2 XOR with Q3. Okay. Now this is the input, that is a D, which will be what tell me now, we can say now this is Q0 XOR with Q2 XOR with Q3, right? The number of clock pulses required. Now let's see this thing, how many clocks required to get back this thing. Q0, Q1, Q2, and this is Q3. Tell me now, initially when the clock is 0, we have initial state is given as, oh, they given Q3. Okay, initial state Q3 is 1. This is 0 0 0. Okay, Q3 they given now. Now you tell me now, first clock what will come? 3 input XOR between what to what now here? Q0, Q2 and Q3. XOR is what tell me now? 1. Odd number of ones now. So this is 1. So will come 1 0 0 0. Next second clock when you apply. So this value which will come to be a 1. Yes, 1 0 0. Next if you apply third clock, so this is 1 1 1 0. And the fourth clock, tell me, so will come it as 0 1 1 1. And the fifth clock, 0 0 1 1. Sixth clock, 0 0 0 1. Seventh clock, 1 0. Okay, here only we got now. Sixth clock only we have got it. So this is the sequence they required now. So how many clocks you tell me now? 6 clocks. Next. Now tell me the next one. The input signal Vi shown below is applied to the flip-flop in a given figure when initially in state 0, assume that all the timing constraints are satisfied. Okay. what will be the output they ask him to find. So this is what type of flip-flop you see this thing, T flip-flop. And for T flip-flop के लिए we can get the things now, tell me. So if the input is 0, hold state, input is 1, it will be toggle karega. So here the clock is there. So what type of clock you see? Negative trigger. So here is the negative edge trigger, negative edge trigger, negative edge trigger. Locate now. Here only we should concentrate. So initially this value until the clock has to come, it is 0. At this location clock came, so you see this thing input. Input is what, tell me now? 1. So that means input is 1, toggle karega na, tell me now. It will toggle, it will be continue until the next clock pulse. Here next clock pulse came na. So this is input is 1, toggle karega. Next again same thing here. Here at this location again, so this is a toggle karega. So that is 1. And this is again will continue like this. So this again it will be toggle karega. And again this is 1, again it will become toggle karega, right? So like this. Okay. So now you can see this option now. कौन सा option satisfy करेगा? Tell me now. Yes, option C. Why this? Next one. So a 8-bit shift register and a D flip-flop shown in the figure below is synchronized with the same clock. The D flip-flop is initially cleared. Now they ask him to find what you tell me now here. The circuit will behave as. Yeah. Look at now here. Now, so initially here we have B7. So this B7 will come here, okay? And here this B7 will come here. Initially this value 0. So XOR will happen now. Then when you apply the first clock, apply karne ke baad, see what happens now here. B6 will come here and B5 will come here. B4 will come here and then B3 will come here. Next we have a B2, next we have B1 and this is B0 and this is B7. Tell me. Next when you apply the second clock, when you apply, see what will happens now here. Second clock when you apply, so then when you apply clock signal, this output will becomes B7. Now here what will come here? Here it is a B6 will come. This is also B6. Now you tell me now here B5 will come and this is B4 and this is B3 and this is B2. Next we have B1 and B0 B7. Next, what else now? B7 XOR with B6. Okay, tell me. Next. So this output is what you tell me now here. This output is B6. Okay, now here this is B5 will come. This is also B5. Next, whenever the third clock pulse, what happens now here? B4 will come here and B3 here. This is B2 and this is B1. Next B0 and next we have B7. This is B7 XOR with B6. Next, what I know? B6 XOR with B5. Understood the pattern? And similarly, when you apply fourth clock pulse, what happens? You tell me now. This is B3 will come. Next, we have B2, B1, B0. Next, we have B7, B7 XOR with B6. Next, B6 XOR with B5. Next, B5 XOR with B4. Okay. Next clock cycle. So this is B2. Next we have B1. Next we have B0. Next we have B7. Next we have B7 XOR with B6. Next B6 XOR with B5. Next B5 XOR with B4. Next B4 XOR with B2. No, B3. Next sixth clock pulse, like this will continue. Okay, so from this what we can say, this is nothing but what? Tell me, what is this you see? What is this you tell me now? This is nothing but binary to gray code only na. Next will come it as what? Tell me now, B1. This is B0 and B7 and B7 XOR with B6 and B6 XOR with B5 and B5 XOR with B4, B4 XOR with B3, B3 XOR with B2. Next, seventh clock pulse will come it as B0, B7, B7 XOR with B6, B6 XOR with B5, B5 XOR with B4 and B4 XOR with B3. Next B3 XOR with B2. Next B2 XOR with B1. And finally, after 8th clock pulse, if you see this thing, 8th clock pulse will come it as like this. So this is B7. Next B7 XOR with B6, B6 XOR with B5, B5 XOR with B4, B4 XOR with B3, B3 XOR with B2 and B2 XOR with B1, B1 XOR with B0. Check it. Yeah, so this is nothing but what? Tell me now, conversion of binary to gray code only na. This is nothing but what you see this thing, conversion of binary to gray code only. Next. Yeah, here they ask you to find what? Tell me, after 4 clock pulses what will happen? 4 clock pulses what will come here? They given it as what? Tell me now, B7. B7, B means what? Tell me now, 11. 11 means we can say 1 0 1 1. 7 means 0 1 1 1. Now you can see now here this is after in the 4 clock pulses, this will be the pattern will come now. So this means this set will be remain same only. So we have, so this set will be remain same. This set will be shifted here. So 0, 1, 1, 1. Next this set will go to here now. So this is 1. XR between these two, that is 1. XR between these two, which is 1. XR between these two, which is 0. So we'll commit as like this now, tell me. So that means which is equal to 7, and this is nothing but 14. Now 14 means E, 7E. Okay. Next one. All of you do like the session. Do like the session. Share to all your friends. Next one. If the counter starts at 000, what will be the count after 13 clock pulses? After 13 clock pulses, what will be the count? Right. So you can see now, first of all, what type of counting you tell me now here. This is a, what type of counter is it you tell me? So this is the ripple counter, J value 1, K value 1 is given. Okay. So here you can see now here, this is LSB and this is the MSB. Okay. Next, what else you see? And so the sequence, what type of counting sequence you see this thing here? Output Q से खा दिया, you see this thing negative edge now here. So this is Q into minus we have given now, that is minus Q. Yeah, minus Q means what is this thing here? Tell me now. अभी दुख में आई ना, दुख बोले तो, so here what should be now here? दुख के बाद will get the सुख ना. So that means which is a up counter. Up counter, and this is the mod. What we can say now, mod 8 up counter, isn't it? Mod 8 up counter. So that means 0th clock we have, the state is 0 0 0. Next, what will be the 8th clock? You tell me now here. Will come 0 0 0. So then after 8 we have 9 is there, 10 is there, 11 is there. So 11, what will come here? 1 1 1 will come. 10 we have 6 na. At 11 we have a 1. So this is 5 will come. And next we have a 12, and this is 13. And 12th clock pulse we have a 4 na. 1 0 0. 13th clock pulse we have a 3. So this is what you can see this thing. But no option matching. चेक करके बोलिए ना भैया, हमने कोई गलत किया क्या? Sorry, this is up counter या down counter? Up counter ना. Why we did mistake? Yeah, 8th clock will come it as 0. 9th clock is 1. 10th clock is 2. This is 3. Next here we have a 4. Next here we have a 5. So this much na. Right. Next. In a master slave JK flip flop, master slave configuration is what? Tell me now. Master is positive level trigger, slave is negative edge trigger. One is given positive level, other one is given as negative level. Okay, master slave configuration. Next, the minimum number of D flip-flops needed to design 258 counter. Mod 258 counter के लिए how many flip-flops required? So if I use 2 power 8, 2 power 8 is how much now? 256 only. So this means with this we have 256. But we need 258 now. So that means 9 is required. So how many flip-flops are required? 9 flip-flops are required. Okay. Fine. Okay. Right. Now you tell me now this one. The JK flip-flop can be implemented by using T flip-flop. Identify the correct implementation. So what we should do? Verification method से करना पड़ेगा. Verification method, that is the most suitable method here. Yes. And JK flip-flop is implemented by using T flip-flop. Right now T flip-flop. So JK flip-flop के लिए what are the characteristic equation we required? You tell me now. We required is J Q bar plus what? Tell me now. K bar into Q. This we required. This characteristic equation we required. So let's see how we can implement. Now T flip-flop is what? Tell me now. T flip-flop. Characteristic equation of T flip-flop is what? Tell me now. T XOR with Q. Now you see, let's verify the option A. Option A we have T. What the T is given, you see here. So this J Q bar, they given it as J Q bar plus K Q they given. Yes, this is T now. So what is the characteristic equation? You tell me now here. This is J Q bar plus K Q. Now, so this is XOR with Q. Right, so that is Q plus, which is equal to what I can say, tell me now. J Q bar plus K Q whole bar into Q plus J Q bar plus K Q into Q bar. Now, so you can tell me now here what will be the Q plus now. So complement we have taken. So this is what? Tell me now here. J bar plus Q, and this is K bar plus Q bar into Q. Into Q plus if we multiply, so this is J Q bar plus this is 0. And again if we multiply here, what will come here? Q plus value. So this is J bar plus Q into what? Tell me now here. K bar plus Q plus 0 plus what tell me now, j q bar. We multiply this thing here, q plus, which is equal to j bar k bar q plus what tell me now, k bar into q plus j q bar. Okay. So here what we can do here, if I take this term is common here, okay, then we have this is q plus, which will come to be a k bar q I have taken common, then this is j plus 1 plus what element of j q bar. So that is q plus, which is equal to, that is k bar q plus what element of j q bar. Yes, this is the thing you can see. So this is the characteristic equation JK flip-flop only na. So this could be the answer. Okay. Next, if the output to a toggle mode T flip-flop is given as 100 megahertz, the final output of 3 T flip-flop in cascade is, what will be the output now here? In clock frequency given na, how much the clock frequency which is given as 1000 mega, they asking to find this. So output of a 3 flip-flops which are cascaded. So that is what we can say now here, f clock by 8, which will come to be a what will be now 1000 by 8 mega. So how much now here? 4 2s, 4 25s, and which is equal to how much now? 12.5 mega. Next, 5 JK flip-flops are cascaded to form the circuit as shown in the figure. Clock pulses at a frequency of 1 megahertz are applied as shown. The frequency of the output F3 is. Okay, F3 case they are asking the output, they are asking to find. Here this is the Q0, Q1, Q2, Q3. Here this output which will be a F clock. At the Q1 output is what you tell me now frequency, this is F clock by 2, and here F clock by 4, here F clock by 8, and here F clock by 16. Next, so that means at Q3 what is this output frequency, you tell me now, that is F clock by 8. So that is which is equal to what, tell me? Yes, frequency given as 1 mega. They ask in kilo na. I can write it as a 1000 kilo by 8. Now it is kilo. Will come it as what, tell me now here? 4 2s, and so here this is 250. So which is 125 kilohertz. Right? One second. Okay. This F clock. Okay, so here we do small correction we did. So this is, here is F, and here it is, what will be now here? F by 2. Here it is F by 4. F by 8. So F by 16. And this is F by 32. They are asking here now. Okay, so this means what will be now here? Frequency of Q3 is what will be now? F by 16. So this is what we can say now, 1000 kilo by 16. 4 fours, 4 250. 2 twos, 2 125. So finally, how much will come? That is 62.5 kilo. Okay. Next, a 3-bit triple counter is constructed using 3 T flip-flops to do the binary counting. The three T flip-flops, the 3 T flip-flop inputs are. So then it should be work like a ripple counter, means it should be toggle mode now. All the input must be, we should give 1 1 1, we have to give it. So that should be what will be now 1 1. Okay, fine. Yeah, that's it for today's sessions, and we'll meet in the next class. Okay, then see you. Bye bye.